Good afternoon. My name is Jim Hallenbeck. I'm the president and CEO of Black Hills AI. And today we're joined by Dr. Manjeet Rege. He is a professor and department chair of graduate programs in software and data science and the director for the Center for Applied Artificial Intelligence at the University of St. Thomas in Minnesota. Dr. Rege is an author, mentor, thought leader, and a frequent speaker on big data, machine learning, and artificial intelligence technologies. In addition to being continuously engaged in teaching and research, Dr. Rege frequently consults and mentors various industry-leading organizations as an expert who provides guidance for building machine learning and AI practice and applying innovative data science approaches. We're also joined again today by Tom Marlowe. He is the president of Black Hills Renewals, and he's our chief technology officer at Black Hills AI. And today, Dr. Rege is going to lead us through his next installment. He's going to be both the intellect and intelligence, and Tom will add that too. And I'm just here for the ride, but I'm going to borrow on their wisdom. But Dr. Rege is going to start us out today, and then Tom will come in and talk a little bit about what we're doing at Black Hills AI and what we're seeing in the IP space for growth in AI. So Dr. Rege, thanks for joining us today, and take it from here.
Thank you so much, Jim, and thank you all for joining us this afternoon once again. In our webinars in the past, we spoke about a number of topics related to AI. Before we got into generative AI, we spoke about supervised learning that basically maps an input to an output, like product classification, for example. You give an image of one product and it will predict what that product is. So that is supervised learning. And then, last time we spoke about one specific application of supervised learning and slowly making our way into generative AI. We got into LLMs and we spoke about large language models, LLMs, and we spoke about what LLMs can be used for. So first off, generative AI generates text. So not surprisingly, it's useful for writing. And one very, very routinely uses generative AI for brainstorming as a brainstorming companion. And last time we spoke about its usage for primarily writing, coming up with, let's say, for ideation, coming up with a new product name, things like that. Then last time we also spoke about usage of LLMs for reading a text that is given to it, and that could be a customer, let's say, review, or it could be an email that arrives. And primarily, you can then further divide that use case into two. One is summarizing, that is, given the large body of text, like reading through an entire code proceeding, or let's say a patent application, but summarize it down, or to analyze. And in analyzing, if you're given a body of text, what is the sentiment here? Is the customer happy with our product, or is it something that needs immediate attention, right? So that's the analysis part of it that we spoke about in the past as well. Our focus today is going to be on the chatbot application of LLMs as well. Now, I work with a number of companies, and what I'm trying to showcase here is how do you embark on having LLMs being integrated into your enterprise. So at one end of the spectrum would be, let's say, a human only application. Let's say you're doing this for a customer service, right? So this is a customer service center with only humans. you would have a human, service agents typing back and forth messages like, welcome to our e-commerce site or welcome to our service, and they'll place the order, or they'll take the information from you. At the far end of this spectrum would be chatbots only, at this far right, where you just have software responding directly to customers. But between these two ends of the spectrum of humans typing on the keyboard or the chatbots only, there are a couple, common design points. One common design point would be to have bots support humans, in which bot will generate a suggested message for a human, but the human service, agent will kind of approve it if it looks good, or have a chance to edit the message before it is actually sent to the customer. So this type of design is often, called the human in the loop. And this is a way to mitigate the risk of the chatbot maybe saying something that is, wrong, or, hallucinations that we have always seen with chatbots as well. So because a human can check over, because before it's actually sent to your customer, it kind of prevents that situation. So this design um, can help protect reputation of a company. A little bit further on the automation spectrum would be if you have a bot to triage messages for humans. Maybe the bot can answer the easier messages, but escalate to a human for the things that it isn't quite ready to handle yet. This type of triaging is another common design to help, your human service agents save time and have and focus only on the harder tasks at hand when it comes to communicating with um, um, people, let's say, reaching out to you. So um, in many customer service centers, a single human may be, simultaneously having chat conversations with 4, 8, or in some extreme cases, maybe even 16 customers at the same time. So with bots supporting the humans, it becomes easier for a human to manage a larger number of parallel conversations. And then slowly, as the technology evolves, or the chatbot that you have developed emerges to a stage where you can fully deploy it, then you can go to the far right with the chatbot only. So given that, bots sometimes say the wrong thing, I want to share with you what building and deploying a bot often feels like in companies that want to do it in a safe way. Often companies will start with an internal facing chatbot, assuming your internal team um, will be more sympathetic and more understanding of mistakes, and be more, let's say, forgiving if the bot says something wrong at one time. This gives you some time to assess the behavior of the bot and also avoid public mistakes that could be embarrassing for the company as well. Um, a common next step would be to deploy with human in the loop, to let the human check over many of the messages. Now, after doing this for a while, if it looks like the bot's messages are generally safe to send to customers, then you might allow the bot to communicate directly with um, customers outside. Of course, the details of every enterprise, every business differs. For some applications, it may not be practical to have humans check over every message because of the sheer volume of traffic. But depending on the risk of the bot saying the wrong thing as well as the volume of traffic, that is something that is an appropriate design pattern to consider as well when you think about deploying a chatbot. Now, generative AI is an amazing technology, but it cannot do everything. Just like every technology, generative AI also has its own limitations. I want to talk about how do you assess what LLMs can and cannot do. And I think understanding the limitations can lower the chance that you might get tripped up trying to use them for something that they are really not good at. So if you're trying to figure out what if you're trying to figure out what LLM can do, here's one question that is considered to be a useful mental uh, framework, which is, can a summer intern, let's say you have just hired, following only the instructions in the prompts that you give an LLM? So can a summer intern, following only the instructions in the prompts, complete the tasks that you want the LLM to do? So for example, can a summer intern follow instructions to read an email to determine if an email is for a product return? Well, yes, an intern could probably do that. And in that case, an, an LLM could do that pretty well too. Um, Here, so again, determine if the customer email has a positive or a negative sentiment. So read through this email and determine if the positive or a negative sentiment, a newly hired summer intern can probably do that very well without any problems as well. Now, let's look at a scenario where you would like your new, let's say, marketing summer intern to write a press release. And the summer intern that you have hired does not know too much about your company, and this press release is for, let's say, a new location that the company is moving to. In that case, if you think about that, there isn't much of a background information. The summer intern might struggle to come up with a good press release. It would be a lot more generic. And the same thing here, an LLM would write a very generic press release, and it isn't something that is going to be, good for a public release. But on the other hand, if you give a lot more context in the prompt, a lot more background information like this, now I think the summer intern, or LLM in this case, has the necessary background information for coming up with an LLM, for coming up with a press release that is a lot more customized to what you're trying to do. So I think that is a, a good mental, I would say, framework. By no means this is a perfect mental framework for getting an idea about what an LLM can or cannot do, but it kind of gives you a guideline about the capability of an LLM. Certainly, there are, tasks that an intern might be able to do and an LLM might not be able to, or vice versa. But largely, I think that mental model, I think, gives us ideas about what an LLM's capabilities are. So when you're picturing an LLM as doing many of the things that um, a summer intern might be able to do. Think of this intern as having lots of background knowledge that they know, lots of general knowledge, but they have to complete this task without, access to a web search engine, right? So when you have an LLM do a task, it is relying on the learnings of the past, but they don't have access to a live search engine. They don't know anything about your business in real time. So, for clarity, this mental model thought experiment has to complete a task with no training specific to a company or your business. And every time you prompt your LLM, the LLM does not actually remember the earlier conversation. So it's almost like, you're getting a new summer intern for every single task. So you don't get to train them over time on the specifics of your business or the style you want them to write. So as I said, this rule of thumb of asking an intern is kind of imperfect, but kind of largely it gives you an idea about the capabilities. It's a useful starting point for thinking through what LLMs can or cannot do. Now, one aspect of data where generative AI may not be great at is structured data. What I mean by structured data is data that is in a tabular format, like in this table that you see here. You have age, income, education level, right? So these are customers, and you have purchased product, yes or no. So given the data like this, I would like a model learned that, given somebody's age, income, and education level, can a model predict if this person might make a purchase or not? Now, something like this, generative AI would struggle at, but supervised learning, something that we have spoken about in our previous webinars, would do extremely well at a task like this, because supervised learning is meant for mapping from one set of features and predicting something else. That is, given age, income, education level, that's my input, predict the output of either a yes or no, that is whether this person would purchase or not. So supervised learning is something that would do extremely well on a task like this. But if it is unstructured, that is, read in this body of text, that is not something I can store into a table, for example. Have a look at this image and tell me what it contains. Have a look at this code and analyze the code. I don't have to be a developer. I don't have to be a programmer. But if I have a programmer who has written the code, trying to understand the logic, I can give it to an LLM and it can understand and explain to me in plain English. So this is unstructured data where generative AI does a very good job at. So recognizing that and using the right tool at the right place is very important. Text generation is what a lot of users are using and is having a very large impact of all the different tools of generative AI. But part of the excitement of generative AI is also image generation. There are also starting to be some models that can generate either text or images, and these are called multimodal models because it can operate in multiple modalities like text or images. What I'd like to share now is how image generation works. How does this technology work? Image generation today is mostly done using a method called a diffusion model. Diffusion models have learned from huge number of images found on the internet or elsewhere. It turns out that at the heart of a diffusion model is supervised learning. And here's what it does. Let's say the algorithm finds a picture on the internet of a dog like this. And it wants to learn from pictures like this and hundreds of millions of other images how to generate new images. The first step is to take this image and gradually add more and more noise to it. So you go from this nice picture of a dog to a noisier, to an even noisier, to finally a picture that looks like pure noise. And where in the end, all pixels are chosen at random, and it doesn't look like a dog at all. The diffusion model then uses pictures like these as data to learn a supervised learning algorithm. And remember, supervised learning algorithm is mapping an input to an output. That is, given an input, it will predict an output. So in this case, the supervised learning algorithm is going to say, give me a noisy image and I will output a slightly less noisy image. So specifically, uh, a data set is created where if you see here is an X to Y mapping. So given a less noisy image like image 2, it would predict image 1. Given a little bit more noisier image like image 3, it would produce a lesser noisy image like image 2, and so on and so forth. So after training on maybe millions of images, when you want to apply it to generate a new image, this is how you would run it. You will start off with a pure noise image. Start by taking a picture, where every single pixel in the picture is chosen completely at random. We then feed this picture to the supervised learning algorithm that we trained on the earlier slide I mentioned. When we feed in pure noise, it learns to remove a little bit of the noise from this picture. And you may end up with a picture like this that suggests, some sort of an object in the middle. We're not quite sure what it is yet. So now we have gone from this to this. Now, given the second picture, we again feed it into the supervised learning model, and it takes away a little bit more noise, and you have a slightly more clearer picture. So now in that sequence, I end up having this. And then again, I feed this into that same model that removes the noise, and you see this, pretty picture of nice shoes in the middle. So I have basically gone all the way from here to here. So this algorithm will work for generating pictures completely at random, right? I did not have it generate a picture of shoes. This was at random. But what we want is we want to control what images get generated from a text prompt. So this particular process that I explained can now be tweaked so that given a particular prompt text, it will generate the image that I wanted to generate. And here is how that works. So let me describe a modification of the algorithm that I explained. And so that lets you add text or add a prompt that you see here. And so in this training data, we are given pictures like this, as well as a description or a prompt that could have generated this dog image. And then, as before, we'll add noise to this picture until we get this fourth image, which is pure noise. But we are going to now change how we build the learning algorithm, which is, rather than inputting the slightly noisy picture only and expecting it to generate a clean picture, we'll instead have the input to the supervised learning algorithm, this noisy picture, as well as the text caption or the prompt. And its goal now is to generate a less noisy image. So if you now think about it from the data point of view, the input is going to be a noisier image along with the caption, and it removes the noise and it produces image 1, right? Same thing, image 3, the caption dog, and it produces image 2. So having learned from a large data set, when you want to apply this algorithm to generate, let's say, a blue SUV, this is what you do. Same as before, we start off with an image of a pure noise. Every single pixel is chosen completely at random here. But if you want to generate a picture of a blue SUV, you input to the supervised learning algorithm the picture of noise along with a caption, blue SUV. And now these random pixels are kind of guided that, okay, we need to come up with something in the middle, right? So now it knows you want a blue SUV, and it ends up generating something in the middle. Now this, so basically now from here, I have reached here. Now, once again, this newer picture that we have is again provided the same caption in an iterative manner, and you get a slightly more clearer picture. So that is what I have now. And again, this along with the caption is again given to that same algorithm, and you get a much clearer picture of a blue SUV. So basically, the caption that we provided kind of guided how those pixels have to be arranged to eventually create an object that I want in those images. Here's what the life cycle of generative AI project to build software application feels like. We would start off by scoping a project to decide what do we want this software to do. For example, let's say you want to build a reputation monitoring system online. The next step would be to actually try to implement it. And given the ease of building AI applications using generative AI, very often you build a prototype quite quickly and then plan to over time improve this software initial proof of concept that you have built. In some of our earlier webinars, I think 2 webinars ago, I had talked about how the development cycle has gone down from months to weeks due to generative AI. So as a result, from project scoping to building the prototype could be done in a matter of days, if not weeks. For some applications, you could build the initial prototype in 1 or 2 days, and that initial prototype, frankly, may not be good initially, but building it quickly lets us then take it into internal evaluation, where we might have our own internal team test the system to see how often it is giving a correct response or not. And sometimes that the internal evaluation will turn out some examples where it doesn't give the right result. And based on problems that we discovered internally, we'll then go back to continue to improve the system. Building a generative AI software application also tends to be a very iterative process. After a sufficient internal evaluation um, that gives you, confidence that the system is working well enough, then you would deploy it out in the world. But once you have deployed it, you know, you have to continue to monitor its performance. We always talk about concept drift, that is the data that the AI model might have trained on might be different from the data that is being supplied to it once it is deployed. And it should not be surprising if you deploy something and initially external users also generate input that causes the system to make some mistakes. And in that case, you might then decide to go back to improving your implementation as well. With that, let me hand it over to Jim and Tom.
Okay, thank you, Dr. Reggae. I appreciate that very much, and that's always insightful. There is a question. So for questions, please enter them into the chat. I guess I didn't mention that at the beginning, so I can see that somebody is raising their hand. If you could instead enter your question in the chat, and then we'll answer your questions on the backside here once Tom and I talk a little bit. So yeah, so Tom, why don't you go ahead and start, and I'll chime in where it makes sense.
All right, sounds great. And again, thanks, Dr. Reggae. Another great presentation as usual. I'm gonna take a minute here to go into a little bit of the application of some of this in the IP space. I think it'll pale in comparison to the interesting nature of like some of the image generation that we've seen there, but it's the field that we're in, so we'll do the best that we can. Particularly here, we're going to be looking to see how value is able to be added kind of in the process with using some of this AI technology. So first and foremost, we've all heard the expression garbage in, garbage out. It particularly holds true in the AI space, probably more than most realize. I like taking a bit of a positive approach from the position of quality in, quality out, or in this case, as the slide says, quality in, value out. If you've joined us in the past on these or similar webinars, you know by now that data is pretty important for any AI project. And the key is understanding what is being collected, what data you're gathering, and what will actually provide the basis for valuable analysis and I suppose actionable insight. And that goes into any AI project, but particularly some of these more chat generative types of projects where you want to rely on some of that data for context purposes. Okay, so just having the data, of course, isn't all. Let's go to the next slide. And it's not just data quality. The key is both how much data you have, but also it's really important how that data is organized, how it's labeled or categorized. As data is processed, in order to know how to query or access or use for context some of that data, a consistency in the organization or naming matters, as does generally the data quality. So inconsistent data organization, inconsistent data quality, conventions and field naming, that type of thing, makes using some of these tools clunky and inefficient and just not particularly useful. You know, and often, we're still on the previous slide, often overlooked is the idea of timeliness. If I'm working on a response, for example, I want to know, does the system have the references loaded and OCR'd and ready so I can query against them or use them as part of context for a prompt? Having this relevant data available in a timely manner is key because it really gets to the usefulness of the tool. And at the end of the day, all the bells and whistles are meaningless without a useful workflow. You know, and that's where accessibility comes into play as well. Again, a tool loses its utility if the data that you need to operate on is not easily, well, accessible. So listen, most of the AI functionality of many of the tools that you see on the market can be likely replicated in one way or the other with ChatGPT or another readily available LLM tool, no doubt about it. The differentiator, at least the perspective we take, is that the differentiator becomes the workflow and making it easy to use AI to operate on the documents and data that are relevant. Okay, so let's go to the next slide. So all of that is really setting up kind of a brief discussion here on how we operate at Black Hills with our tools in this space. So first, I need to stress that the data we keep is based on years and years of processing IP documents and correspondence. We're talking OCR, extracting key metadata, dates, form identifiers, referenced matters, rejection types, key language that can impact docketing and prosecution decisions, all this type of stuff. And of course, organizing all of that data, which can be a task. Knowing what data is important or useful and having that data be available is a big part of this. So at Black Hills, we've got a centralized hub that stores all of this data very securely, of course. That's important as well. And the tools that we have can pull data from this hub for analysis. And because we're a docketing service provider, it's kind of where the roots of the company had began, we have a primary objective of pulling and processing IP office communication every day, day in and day out, in order to keep our customer systems as up to date as possible. So we're able to kind of leverage that, what you might call real-time or same-day processing of everything that we do to help us have the ability to maintain very up-to-date data sets for any IP activity going on for our customers. Yeah.
So let me chime in. Why don't I chime in here just
Please.
a little bit too,
Please.
Tom? And so where we're going here is that we have these AI tools. There's all these AI tools out there. And like Tom said, many of them, they all run on top of the same models, and you can replicate much functionality and capability fairly rapidly by using these existing models. But what we've brought to the table is a user interface, some layers of additional context setting and training and tuning in specific areas. But even more important than that, what we're able to bring to bear, and you'll really start to see this break out inside of our tools. Is the readily accessible data and documents when you want them, where you want them, with direct, great simplicity, and that's fueled by access to our central data hub and being able to place file history documents easily into context for retrieval augmented generation or context setting, as it's also known, when you're interacting with an AI tool. And what that does is that primes the pump, if you will, for getting the type of output you want with your specific case. There's no searching for the documents, downloading the documents, and uploading them to an AI tool and then querying it. It's simply select the documents you want, bring them into context, submit your prompt. But this also gives us other options of rather than simply prompting through a web-based user interface or a smartphone app or whatnot. But it also gives us the options to do additional things, such as pipelining output. With your Office Action Response shell, you want certain types of output already inside the shell, or along with the shell, where you get an assessment of the office action and the references, and if the examiner's onto something or the examiner's may be wrong and why, and so on, and maybe even identifying other anomalies in the file history at the time that you receive an office action, or at any time by accessing an online portal that we offer to our customers to identify anomalies in your file histories and so on. And so what's going on here is that there's this convergence of these different services that are AI based. They're more AI in a generative AI sense, AI in a more expert system context. These are all converging, but it's converging around this periphery of a central data hub. Processing power was the battle of the past. Processing power is pretty much available readily these days, and you don't even have to buy it, you can just rent it. Now, what's really the next step in this evolution of data processing, and in particular in our space in IP, is the ability to bring to bear that processing power, which is readily had, with readily available data, which isn't as readily available. It's there, but not everybody has it in the form it needs or the organization that it's in. It's not necessarily up to date. And when is it up to date, even if it does get up to date? And so we've spent a lot of time building the central data hub, building around it. I'm using my hands. I'm using hand gestures right now without the camera on, but so I'm entertaining myself. At least I'm getting a little bit of exercise here. My watch is probably counting steps while I use my hands, because I get really excited about this stuff. But we have a data hub in the center, and around it, we're building all these services. One of those is generative AI. Another of those is the ability, it's generative AI, but being able to pipeline various things in generative AI. But at the core of that is that central data hub and powerful software that can utilize that. So maybe you can even switch to, I think on your next page, yeah. So there's a slide here. This is just a sample of a user interface that we're working on. On the left, you can select a file. This is within a file history, and the references are readily available because we get that stuff all the time. We get it every day, and it's readily accessible. So we bring this up. You can right inside the user interface, you can see the references, and you can quickly select the reference. You click that paperclip to bring it into context, and you submit a prompt. to summarize summarize that reference real quick. But you could also ask it more, specific questions about, how is this reference, was this reference accurately applied in the office action, and so on. And everything's just readily there. I think on the next page, we might, yeah, so you can see in here, there's an office action. We can scroll this and see the whole office action or whatnot. But over on the left, all the different documents and such are there. You might see those yellow warning signs. That's just this file history hasn't been fully loaded. We have, it's there. It's just this, what we needed for this instance. It's there. The final office action, or not final office actions there. Ask it to give me a summary. If I wanted, I could ask it to bring into, give me an assessment of this office action in view of the reference that we saw on the previous page. But the point here is that we're bringing everything to bear in one location so that you can run your queries, you can prompt a tool, start generating your responses, and quickly do it. But you can do it not just with for purposes of generating new content. There's also, you're limited only by your imagination on how you might input your the different prompts you might put in there, the different documents you might bring into context. For example, you might upload your claims and ask the AI tool to do antecedent basis checking for you, or to ensure that your claims are properly supported by the application as originally filed, which could be quite useful when you're submitting new claims in the during prosecution. You want to make sure they were supported at the time of filing. Checking your your figure references for consistency. You can get predictions on, are my claims patent eligible? Will they be found patent eligible? Am I using any terms? You can do quality control type things. You can do this with both applications before you file them. You can do it with office action responses. You can do it with all sorts of stuff. And that's just on the, the prep and pros side. So by having all of this here in one place, you're able to benefit from the great technologies that Dr. Reggae was talking about before. Think about the chatbot not necessarily in the context of outward facing to your clients, but inward facing to your attorneys, your agents, and your para staff. It provides great opportunities, but in the litigation context, this can also be quite useful because you can bring into context everything in file history of a case and ask, simple things like, as a quick starting point when you're deciding how to respond to a complaint to patent infringement, for example. You can pull up the file history and quickly ask an AI tool to evaluate the file history to identify certain things like, were the arguments that the applicant made, accurate? If those were the arguments made to get the patent allowed. You can identify a lot of things very quickly that you may not, budgets and time may not allow you to do otherwise. So anyway, I get really excited about this stuff, but the material that Dr. Reggae presented is pretty awesome. And on here, by bringing the data in on the backside to set the context, it enables us to use these AI tools in very unique ways for a lot of different things. So, so Tom, did you have anything else there?
Well, we've got a question that
Sure.
I think came up when we're talking about using some of the off-the-shelf LLMs or other models that are available. And the question is, how do you improve when the model cannot be trained further? And I think there is some improvement you can get through fine-tuning techniques. Now we typically don't do a tremendous amount of that because a lot of customers that we work with don't want the data that we're processing of theirs to get used to do any model training, so that limits what's available for training in the first place. Like I said, there is some value in doing fine tuning, but I think the bigger benefit here is that you can improve the outcomes and therefore the usefulness of the system by having better quality data to be able to be used as context, and by having, say, better formed prompting and some of the things that you can build into the workflow to allow the tools to be used even in a more improved way than if you kind of were just using things out of the box. So I think a good way to think about it is that it's not just retraining that improves the outcomes from the models, but how the models themselves are used is a big piece of it as well. And on top of that, some of the models that we do use are definitely fine-tuned in the legal space, and particularly in the IP legal space, based on fully public data, to kind of help get us a nice baseline to be working with.
Yeah,
So
just to,
oh,
sorry.
go ahead. Sorry. No, go ahead. Go ahead, Dr. Reagan.
No, just to add to what Tom said, I think that statement that Tom made absolutely is 100% I agree with. It's not just about model training, but it's also about how you use them. And so model training could be a model trained by Meta or OpenAI, uh, or so basically an open source model. You could have the weights downloaded. Um, so you have all of that training. Now, of course, fine tuning is part of training, but it's also about usage. So when you're using it, no matter how well trained the model is, when you're using it, if you're not giving the right context, if you're not giving the right prompts, then I mean, no matter how much you have trained, your model accuracy will, never reach where you want it to.
Mm-hmm.
So another thing to keep in mind too is that these models, these different like Anthropic and um, OpenAI and Meta and Google and Microsoft, I mean, they're continually developing new models, updating models, retraining their existing models. And so one of the things that you need to do is keep up on what's the best model on the market at the given time when you're looking to choose a model. But you also don't necessarily want to build an infrastructure that only relies upon, can only integrate with one model. You want to be able to change your model when it makes sense for you, for your company. Maybe there's a better model on the market 6 months from now as than when you chose it, previously. So the way that we've chosen to deploy AI is to have the ability to change the model to make sure that we're using the best model at the given time, and stay up with advances in the technology, but yet be able to have our layers on top of that can still provide the same functionality but with improved output. And the improvements can be in terms of speed, accuracy, and so on. Another thing too is like these questions about improving models or getting a better model or whatnot. Don't underestimate though the importance of good prompting, and kind of not just good prompting, but also the strategy that you take in prompting. If you ask for more, Boolean answers, true, false type stuff, or is there, or an absolute answer, left or right, up, down, 1 or 0, you're more likely to get an incorrect result or a less useful result. With most of these tools, if you ask more, you leave the prompts so that you can get a more open-ended or explanatory type response, you're more likely to get a more useful answer, a more informative answer, or or rather than answer, I should actually say response. So the importance of prompting, it's not just training, it's not just it's not just the model, it's not just the training of that model, it's not just the fine tuning of the model, it's how you also prompt it and the strategy you use in prompting. So anyway.
And also, if it's like a yes or no answer, if you have the model kind of explain why it's a yes or why it's a no, that also helps quite a lot in the accuracy.
Mhm. Right. And in the legal space, of course, just a reminder, keep the guardrails on. Don't just take what comes out of any AI tool, whether it's somebody else's tool or our tool or anything else. Make sure you read what read what you're submitting before it's submitted. So to a court or patent office or otherwise. So